All right, this is going to be just kind of a quick rundown of the types of chemical reactions. We can get more into different types later. There's technically 5 types of chemical reactions. Okay, and for right now, you should be able to identify these reactions just based on like looking at a balanced chemical equation. So combination and decomposition are actually opposites of each other. What happened to my pen? So these are opposites. Something combining versus something decomposing makes sense, right? So combination is essentially 2 substances combine to make 1. All right. So the generic equation is like A plus B makes AB. Right. An example would be I have 2 aluminum solid plus 3, and these are all balanced equations, liquid, makes 2 Al Br3 solids. So this is pure aluminum combining with pure bromine to make aluminum bromide for here. That would be a combination reaction. Now decomposition, like I said, is just the opposite. So this would be one substance decomposing, or breaking, decomposes to make, it could be 2, it could be 3, several new smaller substances. So generically, I would have AB breaking down into A plus B. That's what the reaction would look like. So this is what happens with sodium azide. Sodium azide is actually used in airbags, 2Na, to fill them up really quick. So this is an example reaction into gas. So I start with one compound and it breaks into 2 different compounds. Notice I'm not paying attention to the coefficients. They don't actually affect what type of reaction it is. You want to look at the compounds and the elements that are made or used. Okay. Next, we have replacement reactions. So a single replacement is when one element switches places with another element. So one element replaces another. Okay, so generic equation would be I have an element and I have a compound, and like my A and B are going to switch places. So now A is going to be with C and B is going to be by itself. Okay, so here I've got mercury nitrate, aqueous. This happens a lot with aqueous solutions. Sodium iodide makes HgI2 solid and 2NaNO3 aqueous. Okay, so I have sorry, this is the double replacement reaction. Hang on, let me move this down. Sorry about that. A more appropriate example would be like copper solid, so one single element reacting with silver nitrate, AgNO3 aqueous. So single element compound, and then the silver and the copper actually switch places. So now I end up with copper to nitrate and solid silver. Okay, something along those lines. Double replacement then is when 2 things switch places. So essentially you have compounds that switch partners. Compounds switch partners. So like they switch cations essentially to make new things. So you would have one compound AB and one compound CD. So like these guys would switch, my cations would switch. So now I would have C with B and A with D. Okay, so the cations just switch places essentially. So here was that example I had before, mercury nitrate and sodium iodide. So that's 2 compounds. So they just switch their anions. So now I have mercury with iodide, which is a solid, and sodium nitrate, which is aqueous. Okay. And finally, combustion. You're probably most familiar with combustion equations, right? In order to have combustion, they have to react with oxygen. It's usually a hydrocarbon reacting with oxygen, and it produces a flame. And we're generally going to get water and carbon dioxide out of it. So it's usually a hydrocarbon, like I said. So C something, H something reacts with oxygen and makes CO2 and H2O. Okay, real life example would be methane, right? CH4 is methane. If I light it, that's what's in the Bunsen burners in the lab. Methane reacts with oxygen. Remember, you have to have oxygen, and it makes, oh, I'm balancing that. That's a 2. It would produce a carbon dioxide and 2 waters. Okay, so you should be able to look at an equation and be like, oh, that's a combustion reaction, or oh, that's a single replacement reaction, so on and so forth.